Hello and welcome to Vase Projects. We are continuing with design. We're going over the final bit of design before we have to make refinements. The base design. Is the base design dumb right off the bat? Yes. Yes, it is. But there are not very many ways to make a base, and I'm making it out of plastic, so well, let's go to the board. This is the base link. Now, some of you might be wondering, if it's just the base, why need to worry about any kind of design anything? Well, it's because this base needs to rotate. It needs to rotate the entire arm. Because how that's going to work, it's going to cut butter, and then it's going to rotate over, and then it's going to spray it on toast. That base rotation is key to the setup. And there's really only one way to do base rotation. And it's how I'm doing it here. This rotating piece is going to go in the base. And at the bottom is going to be a motor going up through this piece. And that's going to be rotating it. This is a circle, this is a circle, this is a circle. Simple as that. It rotates the whole circle. This female connection with the D shaft goes to the male connection at the bottom of link 1. That's all fine and dandy. The issue with the base link comes from, a few things. One, I need to determine this height. I can't just arbitrarily assign that. That is actually needs to be determined from the dynamics and where I put the butter and the toast. And also, I need to solve the bearing issue. I'm making these pieces out of PLA plastic. They're all being 3D printed. Plastic is rough when rubbed up against plastic. It doesn't allow for free rotation. Having this rest up against that is frictiony rotation, which might cause, thrashing back and forth in the actual arm. This rotation needs to be smooth, or else everything's going to fall apart. And since everything's made out of plastic, smoothness is not guaranteed. It's not really even provided. So the solutions are a bearing, but I can't make a bearing out of plastic, and this would be buying a bearing. I would have to buy a metal bearing, and no, you don't buy things here. So I would have to do some sort of lube or something. Plastic into plastic, and this is filled with some oil or something in there to get it, rotating freely, but that might make it give, which won't make things as accurate. It's a whole mess. And it's a mess that I can't solve until we actually start making it. And in all honesty, the problems that arise from the inaccuracies in this base rotation will have to be solved by making adjustments in the links later on. Like, not the link design, but the link operation. Cutting a bigger wad of butter, or making, using greater surface area of toast. You might be thinking, wasn't that cheating? That wasn't in the rules. I can cut as much butter as I want. I can spread as much butter as I want to. It needs to cut butter, spread it on toast, and spin around. That's it. But yeah, that is a problem I'm having with this one. The only ways I can directly improve this base design would be replace these with some fillets. But that's really about it. And for holding the butter and the toast, I'm going to do something similar to this, or it's like a little stand or something. Yeah, that is all of the links design. Next step after this, we take all of this, draw up an updated dynamics model. And I'm not going to run through all the dynamics math again. You don't need to worry about that. What I do need to do is do the torque from these updated model. And from the torque, determine what motor I can do. Then go back to this design and update all of these D profiles with the motor that I choose to do. And then we can do the CAD models and then print the links. So we're getting close to actually making this thing. It's gonna be good. I'll see you next time.